Hi everyone, my name is Monique Casanova and welcome to What's the Scope? This is a student initiative hosted by Eastern Engineering Group where students get to pick out a structure and we contact a design team to see if they are willing to give us an interview where they will answer all our technical and design questions. Today we are going to be talking about the Frost Museum of Science. Last week, we got to speak with Grimshaw Architects, and today we will be speaking to DDA Engineers. We will be getting a structural engineering's perspective for this project, and we are speaking to somebody that's very special for our firm. I don't think you should miss it. Check it out. Hi, Aida.
Hi, Aida.
How are you? Sorry. Okay. Now, there we go.
How are you?
Good. How are you?
So nice to meet you. My name is Monique and this is Shannon.
Hi, Shannon. How are you?
Good.
Good.
Very excited to talk to you today. Thank you so much for joining us.
Great. Same here.
All right. So just like I said, my name is Monique, and on behalf of everyone at Eastern Engineering Group, Aida, we want to thank you so much for taking the time out of your day. We're very excited to talk about the Frost Museum of Science now with a structural engineering perspective. And
Okay.
I'm just going to give like a little background of your firm. DDA Engineers is a structural engineering consulting firm founded in Miami-Dade County in 1969. And this amazing firm has been involved in very iconic projects. And one of the examples is the Frost Museum of Science, which we're going to be talking about today. And Aida is currently a managing partner in this firm. And Aida, we're very excited to speak with you today because you have been a mentor for Raisa, which she's the president of our company.
Sure.
And she's been saying just a bunch of positive things about you as a professional and as a human being. So, I mean, Shannon and I are just very honored to speak with you today.
Great. No, thank you. Same here. I love Raisa, so everything is good.
Yes. Thank you. So, Shannon, do you want to give a little introduction of yourself?
Yes. Aida, thank you so much for taking the time to be with us. I really appreciate it, and like taking the time to share your expertise in this field. And I'm really excited to learn more about the structural engineering behind the Frost Museum of Science.
Okay.
My name is Shannon Stever, and I am entering my senior year of civil engineering at Florida International University, FIU. And in the fall,
what year? What year? I'm sorry.
Senior year. I'll be entering my senior year.
Okay.
And I'll be starting to take graduate courses in the fall because I'm doing the combined degree program of FIU's combined bachelor's and master's program.
Okay.
And I'll be concentrating in structural engineering. So I'm excited to learn more.
Great. That's great. Well, hopefully, Raisa, hold on, I'm just closing my door. Hopefully, you could learn a lot from Raisa and everybody there, just as Raisa did here, and we're so proud of her that she went on to open up her own firm and is doing so well. Welcome to the profession.
Thank you so much. I'll definitely let Raisa know, and she's going to be so happy that we spoke to you. We're very excited. Yeah. Shannon has very cool questions for you.
Okay.
Awesome. Do you want to start?
My first question is, I read that renewable and recycled materials were used in the creation of the museum. How did you decide which materials to use for this project in order to achieve LEED certification requirements and uphold the Frost Museum's commitment to sustainability and green infrastructure?
Okay, so that's an interesting question. Unfortunately, as structural engineers, we don't get to participate much on the LEED of a project. In this project, it's a concrete structure, so we get LEED points for like using fly ash and other admixtures in the concrete. But other than that, most of the lead points comes from the mechanical and ventilating systems and other, aspects of the building. We just design to support what they need.
Oh, okay. I didn't know that. I thought
Yes.
maybe the structural engineers, like, I knew about like the deciding materials, but I didn't know like how much they decide on the LEED certification requirement.
Yeah, a lot of it has to do with a big portion is the mechanical engineering, like the heating and ventilating and the HVAC systems, how efficient they are. I know you asked a question later on about the collecting rainwater. All that has to do with LEED certification. They get points for how close they are to public transportation, and if you could ride your bike to the site. Materials is a part of it, but a much larger part is these other aspects of the project.
Okay. Oh, that's
Yeah.
interesting. Thank you.
But it is interesting, yes.
As for like, I read that the Frost Museum is very open, although it's like multiple buildings together, but it's very open. And that also kind of goes with the sustainability and just trying to achieve that like feeling outside, but still being in a museum, like for the visitors. So I was wondering, like, I would like to ask you, were there any challenges with designing a museum with a lot of open space like that? And were the internal and external pressures affected? And if so, how was it resolved?
Okay, good question. So when we start designing a building, we use the Florida Building Code that sends us to ASC 7. Right now we're using 710, soon to be using, I think, 717. But the building code is very prescriptive, and they don't know what your building looks like, and it's impossible to cover all building types. So calculating the wind load in accordance to the building, to ASC 7 is very limiting. And what we do is structures like this that, like you say, are more complex and are not like a rectangular building, is we mostly encourage the owner to get a wind tunnel test done. And that's what was done with this building. So a company called RWDI models the building. We model the building, and we give them the dynamic properties of the building, and they input that into their system, and they put the building in a wind tunnel test, and then they provide us a report that tells us and accounts for all those all that geometry that you're talking about is incorporated into their report, and they give us a wind pressures and we apply it on the building. So that's how we dealt with that.
Okay. So that's how you would also like to ensure the building can withstand like hurricane forces, like extremely strong winds.
Yes. They put it in a wind tunnel test and they simulate a hurricane. And they put gauges on the model, and the gauges translate into a pressure, which they give us a very detailed report with elevations of the building showing the pressures on all surfaces, even ceilings, out exterior ceilings underneath, soffits, the roof, all aspects of the building are in the report. So it's a very detailed report. And they model it in the location where it's at. So this building being at the end of Government Cut, basically where all the cruise ships come in, that wind tunnel test will account for any winds, if a hurricane came, that's coming through that channel. So it captures all that.
Wow. Do you know what kind of system is used to make that model?
Or
they just send the report?
No, they actually do a 3D model of the building. And you could Google it. There's images of that they show the model, and they show the wind tunnel. RWDI, before the recession, used to have a wind tunnel study. Actually, I think they had it at FIU, if I'm not mistaken, I think FIU has a wind tunnel testing facility, right?
Yeah, the wall of wind.
Right.
Yeah.
So, I don't know, exactly how they do it, but they do a three-dimensional model. They have a computer, program that goes with it. They have the gauges. So it's very interesting. We do that on a lot of the buildings that we work on.
Oh, that's
So,
really awesome.
yeah.
I'm
I
taking.
actually have a model of, excuse me 1 minute. I know I left the screen. Sorry. We've also been working on the North Terminal, the NCL terminal in the Port of Miami. And this is the building, and this is a model that RWDI made for us. It's a miniature of the building. The model they make is a little bigger than this, maybe 2 to 3 times, but this is more or less the size of the model. And they start putting gauges all over the building when they put it in the wind tunnel. So that's
so cool, because I think that's for Norwegian, right?
This is Norwegian Cruise Line. Yeah.
Yeah.
I think Shannon and I, we've seen like a couple of their plans and stuff, and it just looks, I mean, it's like a mini version of it.
Yeah,
cute.
it is. Yeah.
It's so true. Yeah.
Yeah. Yeah. So
that's awesome. The next question I wanted to ask you is that I read that the pouring of the concrete for the Oculus lasted 25 hours, and the concrete started sliding downhill, so the engineers had to create a mixture thick enough to prevent the concrete from slipping. I also read that the engineers had to vibrate the concrete during the pour due to the steep angle the Oculus is set at. Can you elaborate on this? And did you as engineers have like any input on this?
yeah. So from the moment that we were in design of sorry, somebody came by and was saying hi. Since the moment we so that was obviously one of the most challenging portions of this project is the Gulfstream, what they call the Gulfstream tank. So the Gulfstream tank, is where all that, it's their flagship of the museum. So they described it like a martini glass that they like kind of flipped on the side and like cut this piece. So when you hear the architects talk about how they thought of the shape, it's very interesting. So they always knew that it had these sloped, very sloped sides. We obviously had a construction manager on board during the design process, which was Suffolk at the time, Suffolk Construction. So during our design, we were always getting feedback from the guy who was going to build the building, which was good. And they had Baker Concrete involved. Baker Concrete is probably the biggest concrete shell contractor actually probably in the whole United States. I don't even know if they're worldwide, but definitely in the United States. So they get involved in these complex buildings, Baker Concrete. So we had, input from them, but the actual construction, so I think they did some mock-ups on the side of pouring and everything to make sure that they got this right. So they had already, once they started the actual pour of this tank, there was no going back. So they really did a multiple test on a mock-up off of the actual tank, to make sure that all those procedures were in place. Now, that was planned. It got delayed multiple times for different reasons. But once they decided it was go, it hit the news, and we had multiple shifts of inspectors because we were threshold inspectors on the project as well. And we had multiple shifts of inspectors because it was 25 hours. So you can't ask people to be out there for 25 hours, although just for the interest in it. So we had different shifts of inspectors that were out there, and very interesting. All that rebar, it had to be a one pour because they wanted a monolithic pour, no cold joints anywhere. So it was a very successful pour in the end. They didn't have any problems. So it was good.
That's really interesting.
Yeah.
It must take like a lot of like kind of like practice, like precision to make sure you get it right.
Oh yeah, no, it was lots of meetings with the concrete supplier, lots of meetings with the shell guy and everything. Planning on they had to have they pumped the concrete, so they had to have like extra pumps in place in case one went bad and they had a replacement. A lot of backup stuff, just in case scenarios covered, so that if something happened, they were covered. They could bring another pump. They had other plans on call. They had multiple precautions, during that pour because it was so critical. But it all worked out. It was very, very good.
And it turned out amazing.
Yeah, and it turned out amazing.
It turned out amazing. Yeah.
And the concrete, another interesting thing about the concrete pour is that the concrete mix, the concrete had an admixture in it that's a waterproofing admixture, which has become more popular, but at that time it was not something that was so common. So it has this waterproofing admixture so that if there ever is cracks in the concrete, the minute water touches that admixture, it like expands and seals the concrete.
Oh, wow.
So it's
very
interesting.
That is very cool.
Yes. Yeah.
I also wanted to ask, like, were there any other challenges you encountered with designing of the Oculus as well as the planetarium? I mean, both of the structure, like those aspects of the structure are like admirable.
Unique, both unique.
Yeah.
Yes. Yeah. I mean, the whole museum was a challenge, right? I mean, so people get excited, even young like you would come out of school as a structural engineer and say, oh, I want to design like a really tall building, it has to be really cool. But let me tell you, this is just as challenging or more challenging than a high rise, right?
Absolutely.
Because a high rise, you have to design for winds and that, but you have a typical floor that gets repeated I don't know how many times, and then that can burn, right? The wind is exciting, but here every time you turn a corner there was a new challenge and a different aspect of the building that required your attention. So not only was it the Gulfstream tank, with had to be waterproof and had to hold that Oculus that you talked about too, that was built in Italy and shipped over in 2 pieces, and that was delayed for a while. So we had to do a compression ring at the bottom so that when this thing sat in there, it wouldn't open up. The planetarium also had a tension ring around the top because the bottom bowl was cast concrete and then the top was precast that came in and that. So it was a combination of elements. You had the sloped seating inside that's all poured. In the living core section of the building, you have a bunch of other exhibits that are poured in place. The Sea Ray touch tank. There's like tanks that go from the second all the way to the fourth. All poured concrete, all sloped with different kinds of these acrylic windows that you could look in. There's acrylic windows that you could stand on and look down. So that living core was highly complex with the geometries and everything. So every aspect of the building was a challenge.
That's really.
I know you asked in another part about the exhibits, and that was one of the challenging parts too, is the loading, because not only did we have the wind loading, but we had a very strong or high live load requirement from the owner, because they wanted the flexibility to put exhibits anywhere. So a lot of the building is designed for 250 pounds per square foot of live load, which is very high. I mean, for an assembly space, which, you could have people one next to each other, you design for 100 pounds per square foot. So 250 pounds per square foot is quite large. And they're thinking, a tank of water or an aquarium or something that they could move from one place to the other. They wanted the flexibility of not to have to call the engineer every time, hey, can I put this tank of water here in this room? I mean, he already knows that it's been designed for that. And some of the corridors where they would be transferring fish and stuff was designed for 450 pounds per square foot of live load. So they have to bring the fish in from certain areas and then bring them over, like some of those bridges, and then acclimate them into the Gulfstream tank. So, and they come, when they bring those fishes, they come in tanks full of water. So a lot of that coordination was quite challenging. Also, the support system, they called it the LSS, the life support system for the fish in the tank. There's all these pumps on the first floor, really like the basement of the museum. And the pipes are huge, and they come up the building, and then they go over in the bridge underneath in the ceiling, so you never see it, into the living core, and it feeds the tank, the Gulfstream tank. So it's like, 24-inch pipes full of water that are hanging from the bridge and bringing continuously water and filtration and everything into the Gulfstream tank. So those are more loads that you had to deal with.
Wow.
So it was another challenging part was the ground floor, the parking. I don't know if you noticed, but the parking area is pretty much an open, the sides don't have walls.
Yes.
So that area is below flood. But
yeah,
then
I was thinking about that.
Yeah, that's below flood criteria. But then there's a portion of the building that is closed on the western and northern portion of the ground floor, which is where all these pumps are. It's not open to the public, but the walls are solid concrete because they had us design like if the water came up all the way to the plaza level. So from the plaza level down is designed like if the water around us came up to that level, to the plaza level. So all those walls are solid concrete and resist like a pool, like water pressure against those walls. All the doors are sealed, and so they plan for sea level rise or a flood or a hurricane coming in and bringing the bay against the building. So
wow, it's really interesting how like all those little aspects are implemented into the structure. It's incredible.
Yeah.
It's crazy because I don't know, I thought maybe whenever you would have received like the architectural plans, it would have been like, oh, there's this big ball as a planetarium, like that's so challenging. But saying all the other things that you have said so far, it's like, yeah, I don't even think they were concerned about it.
All right. Yes. There's a lot of other things. There's the obvious and then the non-obvious.
Yeah, exactly. That's what's so interesting about structural engineering, because like you go into a building and like you don't know how much work goes into it,
Yes.
And especially that museum, you're like, wow, everything's so beautiful, and like there's so much engineering behind it that people don't realize, and I think that's super interesting, and that's why like I'm excited to be here, because I went and visited, and if you saw probably my questions, my dad and I were there talking about how open it is, not only in the main area, like in the middle kind of, but like talking about the curved walkways behind the big planetarium. We were talking about it actually started pouring when we were there. So we were thinking like, this isn't like a typical building. Now you have rain kind of coming into the building.
Right.
So we were talking about how like we noticed how the floors were pitched for draining, and we're just like, wow. Like we were talking about engineering over here.
Right. Yes.
And just those kind of small things, it's interesting to me how it all comes together and works out.
Yes.
And also how you were talking about the weight of water. Water is so heavy. One of the things I was curious about too is like, how were you like what kind of parameters did you use to design the columns to hold up the Oculus? When I was walking around and noticed these huge round columns, and like, I read that the Oculus weighs together with like the concrete and the water is like 9 million pounds.
Yeah, I don't know the number offhand, but anyway, we modeled it, and did obviously something like that. You check more than once and you peer review it and you have other people look at it in the office, and we make sure that we're all crossing our T's and dotting our I's, like they say, because it's such a critical portion. But it was modeled in ETABS and run numbers by hand, the weights and everything. Those columns are challenging because they were an architectural feature to the project. So the columns start square at the bottom and they flare up, the ones that hold the ring that holds the tank. So they flare up, and at the end they're like 6 feet by, very rectangular. So they flare and they're at an angle. And they had to be done in one pour as well, because the architect didn't want to see any construction joints, and it's exposed concrete. So those columns not only were a challenge to design, but a challenge to build. So for design, they go up at an angle, and they flare at the top, and then when they come down they're very thin, so they put like a horizontal load on the floor as well as not as a concentrated load. So we had to put extra reinforcing in the floor to take that load. And then to build, since they didn't want to see any joints, they had to come up with a way, working with Baker Concrete, come up with a way of pouring it. And for Baker Concrete, that was a big challenge. As a matter of fact, they tore down the columns 2 or 3 times before they got it right. But they decided to pump the concrete from the bottom, which I've never seen. So they used pressure. So they put the form up, and then the form had a hole on the bottom of the column, and they actually pumped with pressure. So the concrete went up instead of starting at the top and just pouring down. So the one time that they had done it just perfect, they had miscalculated the yards of concrete, and they were missing like the top 2 feet of the column. So they were very happy that they had finally figured out how to do it, but they ended up having to tear it down again because they had calculated. I mean, that part was a mess, but they finally got it right, and then poured I think there were 6 or 8 of them, so they were working on one, just trying to get it right. And finally they did, and they poured all 6 of them. So it's everything was a challenge, like you see on that project.
Yeah, absolutely. I didn't realize, like, I didn't know all the even little but big things that went into it, and that so many different people had to face.
Yes.
It's really interesting.
Yeah. And then some of those, there's another row of columns outside those main ones that you see in that people and science room, I think it's called. But outside, there's a row of columns that are like laid out in a circular fashion that pick up the deck that you walk on when you walk around the Gulfstream tank. And that's a space that you really don't see, because the inside has partitions and the outside is the facade of the building. But all this life safety stuff that we're talking about, all the pipes, the air conditioning, all of these things go in that space. And those are like wall-like columns that we had to coordinate with the MEP engineer, and they make holes in them for all the AC and plumbing and everything. So there's a lot of coordination there with the other disciplines to make sure everything was accounted for.
Wow, that's really interesting. Yeah. Like how, like all the coordination that goes into it.
A lot of coordination. Yes.
I also wanted to ask you, I'm not sure if this is a question for you as a structural engineer. I was just like curious also, when visiting the museum, I noticed that the elevator was like exposed, whereas typically an elevator is, you only see that one side, the door to go in. But this elevator, you can see the entire thing, including the pulley system. Mm-hmm. And like, it's something that I noticed because kind of stood out to me. And like when I went, it was last summer for World Oceans Day.
Mm-hmm.
And they had like demonstrations and activities all around the museum. And one of the activities was demonstrating the mechanical advantage of a pulley system.
Okay.
So they had like 3 chairs, and then one had like with 1, 2, and 3 pulleys. So like you would sit in it and pull yourself up with a rope, and like in each chair, and you would see like it got easier with more pulleys.
Oh, okay.
So it's just like a fun activity. And
Right.
then like walking around the museum, I'm like, look at that pulley.
Right. That's good.
Elevator. And
That's good.
My dad and I were talking about like, you know, kind of going off of the talking about the mechanical advantage of the pulleys.
Right.
And after seeing that small, simple activity. And I was just wondering, like, was that like an intention, or, you know, I was thinking of asking just because maybe, because I that might be more of an architecture question, I'm not sure, but because I imagine like the structural engineers would design at least a wall around it,
Right.
but in this case it wasn't.
Right. I mean, we did have to design. So yes, it is an architectural question, in that it was them that decided that this is what they wanted to do. And I'm sure that the thought behind that was that what you're saying, you know, we're in a museum, so whatever we could make a learning experience, why not do it, right? So leave it exposed if somebody can learn something from it. And so yes, it was done on purpose because that's what they intended. And then to support that elevator, since it's so open, you still have to support it. So there's like these outrigger beams that come out and support the rails of the elevator. And then at the top, we had to support the machines of the elevator. So there's like some more outrigger beams at the top that where the machines sit, and all that pulley system, you know, to bring the elevators up and down. So everything is a coordination between all disciplines, architecture and mechanical, plumbing, and us. So it's very, you know, you got to work very closely. And the Revit helps with that tremendously. Doing the project on Revit, you know, where we're all working on a model and together. And especially the Revit has come, you know, I was not a fan of the Revit at the beginning because it's just a lot more work to put a building in Revit, and it continues to be a lot more work. But there are certain projects where it really merits the effort, and this was one of them. And today with 360, where the architect is working on the Revit in the cloud and you're working on your Revit in the cloud, and they're always together, so we can see right away when the architect moves something, and they can see right away when we put something. So we're constantly working on the same model in the cloud. So it's very good.
I didn't know that you could like edit at the same time.
Yeah.
That's super helpful. Almost
Well, you're working on it really independently, but it's in the cloud, and the minute you just press a button and say zinc or you know, whatever actual, you know, it appears in your model. So we could be working on it, and then the architect updates something and says to sync it, and then we see it. So it's
kind of going on that same line, just because I love that you've been talking about teamwork so much, and just because a lot of students are going to be watching this, I wanted kind of your advice for students as team players, since right now that they're in school, I know that they have a lot of team projects that they have to do, a lot of team efforts. So what would be your advice as a team player?
First of all, I think it's great that the schools are doing that. Wasn't so much when we were in school a lot of times, but it's very good because that's the business. You have to be a team player, and you have to be open to listen to what other people are expecting and react. Don't be negative. Always positive, right? So every challenge is a good challenge, and you know. And no client wants to hear no right away, you know. They want yes, or let me think about it, right? So not no. So there's never a problem that can't be solved. Sometimes it's expensive to solve it, but you know, you have to give the option like we can do this, but these are the consequences of that. But working together in the office, outside of the office, everywhere, you're always going to be working with people. This virus that has us all working from home or remotely is difficult for us as engineers and architects and everything, because I mean, for me, or for like older engineers that already know the process, we already know what people expect, and we kind of, we could do it from home, and do these kind of Zoom meetings and stuff. But for the young people, you really need to be in the office and around people to learn, because you're not going to learn. There's so much more learning to do after you graduate. It's not, you're learning the foundation, really. And then when you come out, and start interacting with other engineers and draftsmen and see how everything works, you really have to be in an office environment to do that. So I really hope that we all get back into the office and continue. I mean, we have to think of how we do that safely, but it's important for our profession to interact with people, and that's how you learn, sharing ideas and bouncing off each other, and never a dumb question. So my advice is, yes, keep an open mind, and be willing to participate in discussions, and say what you feel, because nothing is stupid. So you might come up with this brilliant idea that nobody had thought of in how to solve a problem. So no building is unique. No building. Every building has something that you learn something new on. So,
absolutely, it's always something new to learn.
Yes.
And this, being at home, it's just another challenge for us to tackle. And maybe it's not, what we expected or want, but it's, it's teaching us to how to be stronger as a team, because it can be difficult, but we make it work.
Yes.
I agree, though. It is super helpful to be physically there in the office. It's just not the same of being a student in learning.
And even if you're not working on a project, you're listening, people are discussing stuff around you, and you learn just by seeing what's going on.
Absolutely. I agree.
Yeah.
True. Do you have another question, Shannon, or?
My last question I wanted to ask you was, what is your favorite aspect of the museum?
Favorite? Favorite aspect. Well, the favorite is that we did it. So I mean,
you did
that's one of the great things about what we do, is when it's done and you can walk up to it and enjoy it. It's like, wow, this was, I saw it as a drawing. I walked through the model in our office so many times, and now it's done.
Yeah,
it's so satisfying.
So real.
Yeah, it's
for it to come to life.
That one was extra special. Like, they invited us before they opened it. They just invited the whole design team to do a private viewing of it. So I took my family, and wow, it's very satisfying, to see. Yeah. But
cool.
I can't say there's one favorite part. Everything is very interesting.
The Frost Museum is the favorite part.
Yeah, exactly.
It's very rewarding.
Yes. Yeah.
All right, Aida. Well, kind of as a closing question, I want to say maybe 90% of the network of students that we're involved with at FIU, they belong to ASCE, the FIU chapter. So I kind of wanted your input of how this organization has been beneficial in your professional life.
Okay. Let's see. It was very important for me when I was in school. That's for sure. As a profession, I haven't been too involved in it, unfortunately. I find that it's more civil oriented, more water, transportation, DOT, that kind of aspect of it. I mean, and it's a shame. I mean, we get very busy and we don't have much time for these other organizations. I do get their newsletter and read it. You know, they have lots of stories of what's happening around the United States, and you see different projects that are going on. So as a source of information is very good, and they keep you updated on what's happening, you know, with licensing and this and that, and they have a very good insurance program that we all participate in. So that's good too. But as a student, it was excellent. You know, we had such a good time and team building, like you say, you know, working on those concrete canoes and the trusses and all those conferences that we would go to. Excellent. So
I learned a lot.
Great. So have you started taking like all your concrete classes and all that, or?
I just took structural analysis. So
Okay.
in the fall, I'm going to take reinforced concrete.
Okay.
And then for my first graduate course, I'm going to take wind engineering.
Okay.
So that's why I was like super interested in that.
Right.
I'd also like to be taking geotechnical engineering, water resources, but I do, you know, those are part of the civil program, but I do want to do, my graduate will be focused in structural engineering.
Right. Okay.
So my bachelor's and master's will be like combined. So I finish in 5 years total.
Okay. Great.
But yeah, I want to like do structural engineering.
Great. Well, good luck. And if you need anything, let me know. Here to help. Always willing. So.
It was awesome when Monique mentioned that you were like Raisa's mentor. I was like, wow, that's crazy. That's crazy. That's really
Yeah, no, it was fun having Raisa here in the office, and we learned with each other. So.
Oh, I know. Yeah, she says very great things about you. And whenever, I mean, I told her we were going to speak to you, she was very excited, and she was just like, I mean, she told us that we were going to learn a lot of from you. So
okay, I hope you did. I hope you did.
Oh yeah, for sure. Such interesting answers. Thank you so much.
Okay, no problem. Thank you.
Awesome. Yeah. Well, Aida, thank you so much. I know me and Shannon, we're trying to maybe do like a little field trip to the museum once everything is over, and with a couple of other students. So we'll definitely reach out to you to see if you want to come with us, or if you want to have a Starbucks with us.
Sure.
We want to thank you. It has been such a pleasure meeting you today, and
great.
Thank you for being part of this initiative.
Same here. Same here. If you ever need anything, let me know.
Thank you so much. I really appreciate your time and explaining all my questions.
Bye, guys.
Stay safe. Stay safe.
Stay safe.
All right. Bye.
Bye.